Good afternoon, everyone. Has everyone finished filling out the form? All good? Wonderful. My name is Daniel. Welcome to CS Digital. I'm going to be your host for tonight. And let's kick off with some housekeeping. First of all, you all got this little paper here with the login details, and you should have another one with the Wi-Fi. Everyone is on the Wi-Fi, yes? Because it's not, the web terminal won't work unless you are on this Wi-Fi. Cool. Some other housekeeping. If I see quite a few new faces, so just for your information, the toilets are over there, just next to the kitchen. Feel free, obviously. Also, feel free to use the kitchen at any time. Grab a drink if you're thirsty. And last but not least, we don't have any scheduled fire alarms going on or drills going on. So if you hear a fire alarm, please leave the building. Okay. So welcome again. A few notes about me. My name is Daniel. I work at CS Digital as a DevOps consultant. I'm from Hungary originally. Came here to London in 2013, doing IT ever since. So, as a matter of fact, I'm doing IT about 10 years or a bit more. I always say I'm a sysadmin at heart, but in later years, I now feel like I'm becoming a bit of a buzzword addict myself, as technology and everything develops. You can see few of my favorite buzzwords here. Not all of them. The page wouldn't be enough. So that's pretty much about me. Let's check out what's the agenda for tonight. We're going to have a brief history lesson about what Prometheus is and why does it exist anyway. Then we check what we normally monitor, and how does Prometheus fit into this question. And then one slide about the architecture. Then we're going to have a play and see what the basic features and the basic expressions in Prometheus are. And obviously, what's the most important thing on the agenda is the last one, beer and pizza. Okay? I'm pretty sure you can't wait there. All right. So what is Prometheus and why does it exist anyway? Let's start with the second question first. So in 2012. We had a lot of monitoring system in place. We had the big traditional ones like Nagios and Zabbix and all of that. But modern open source time series database was not a lot. Most of that was Graphite. Who's familiar with Graphite? Who's using Graphite? Nice. Good. So the industry was changing quite a lot. Smaller services, more servers, and it just started to become a little bit too crowded there in Graphite world, especially. So there was a huge need for a new open source based modern monitoring system that was a little bit more cloud native. It didn't rely on any particular infrastructure, and you could very dynamically monitor different kinds of metrics. So, okay, history. In 2012, as I mentioned, there's this idea came up with a guy called Matt T. Proud, who then later joined SoundCloud with another guy called Julius Volz, and brought this idea into SoundCloud, and they bought the idea, and they had an opportunity to start developing it. And quick jump to 2013, they started adopting it internally, but it was still a side project. By 2014, we had the first external users, but it was it's not very useful. They did a major refactoring, and they eventually released the software in 2015. That's the official release date, but obviously there was lots of people using before that, and this was the year when it became fully open source, and it's not tied to SoundCloud anymore. And then Prometheus joins CNCF in 2016, Cloud Native Computing Foundation. If you don't know, very important. This was the second hosted project after Kubernetes, which tells a lot, I think, of where our industry is going. And then another major release was end of last year when they released Prometheus 2.0. That was a major improvement, lots of fixes. And now we're becoming quite a good and let's say production grade system. Okay, so before we jump into Prometheus's features, let's just quickly catch up on what do we monitor normally. All right, it's not going to be any new. I assume that 99% of you is familiar with it. But let's just quickly catch up on what these things are. Obviously, the most obvious thing is that we monitor our servers, our virtual machines, or our bare metals, where we like to know all of these things. What the CPU usage, or the memory, disk I/O, maybe motherboard temperature, etc., etc. Nowadays, we also collect information about our applications, every kind of applications, and every kind of metrics, obviously. A button clicked, order has been placed. And we have lots of different devices, lots of different medium platforms that you can collect metrics from. And what is most exciting for me is the IoT stuff. With the rise of Raspberry Pi, we had all sorts of different new metrics that we can monitor: voltage, GPS coordinates, and all that kind of jazz. I don't think I need to tell more. And the idea behind Prometheus is that, okay, so how about we do something? We create a software that we can monitor everything in this field, and we have a good query language, and we have a resilient backend and so on, and we have obviously lots of different connectors that we can utilize in our work. Okay, so let's bring down how does Prometheus fit in here. So if you are familiar with Graphite and all the systems, they have a very linear data model. They don't have many dimensions. InfluxDB is an exception here, but it's not that widely. Well, it's supported, but it's not like common. So Prometheus has a multi-dimensional data model. It features a very powerful query language. We're going to see that a little bit later. They did a lot of work on how to make a storage efficient. As nowadays, almost every single application is using the single binary approach. So they do one thing only, but that's really, they do it really good, and they're very modular. They have a robust alerting platform, also modular. You do the triggering in Prometheus, but you will alert in somewhere else. We talked about application monitoring, yes. So we have a lot of client libraries that we can use for in our softwares to actually expose an endpoint that will be able to produce metrics for Prometheus. We'll see that in a second what I mean. And they did a very good job on themselves, Prometheus as a project, and they did a very good job on creating adapters for legacy applications and legacy systems. A lot better job on service discovery integration, which is probably not that common right now. If you check out, if you see the whole industry, but it's becoming more and more popular, obviously, as the numbers of services are growing. We can't not have service discovery. And I think it's very, very important to tell that it's a very different approach that Prometheus is take than compared to Graphite, because they're pulling metrics from endpoints and they're collecting it in their database. They're not. We used to push metrics. We have these agents on the machines. They're pushing metrics to StatsD. The StatsD aggregates it, put it into WhisperDB, and so on and so forth. We're not doing that anymore. We're doing the other way around, which makes it very cloud native. You know, in the cloud, we always do HTTP and other communications over normal HTTP. So that's how it's fitted. Now, I'd like to highlight two things here, and the reason why this is the reason why I put them up there. The first thing is multi-dimensional data model. I mentioned that back in Graphite's days, we had this kind of model where we had the name, the server, or whatever else, the method, and the HTTP status code and some value. Now, we talk about that why it's not ideal in a minute. But then Prometheus has a slightly different approach. It's a metric name, a value, and lots of other dimensions, lots of other key value pairs that makes it very nice to filter. And so it comes from this. It comes the second most interesting thing, which is the query language. In Graphite ways, could we do something like this? I don't think we can. If I'm just curious about the HTTP response codes and I want to aggregate my metrics like that, it's not easy to do that, right? So in Prometheus, however, it's easy like this. You're just curious about your metric and your filter. That's about it. So, architecture next. It looks complex at first, but it's not that bad. As I said, Prometheus is mainly working in a single binary approach. So where they have the Prometheus server as one single binary, and there's lots of other little binaries that help us do the work. The Prometheus server binary itself is responsible for finding targets that it will scrape for metrics. That can be file-based or can be integrated with some service discovery method. It's actually scraped these targets. It stores metrics on the local disk. Using the PromQL language, you can query them through the UI or any other API, and then utilize rule files to actually trigger the alerts. We'll see that at the end of the demo that it's file-based, but because of the service discovery integration, you would not care about that much anyway, because you can just do a console template or something, and you can update your rules. Very, very powerful. So Prometheus server does these things. Service discovery integration I talked about. The main part is over here when it actually pulls the metrics. Now they have different kind of things here. They call them exporters. The targets, they're exporters that publishes a /metrics endpoint by default, which can be targeted by the Prometheus server to scrape metrics for. And then the other powerful thing is the alert manager, which is looking for Prometheus server's rules, triggered alerts that was triggered by rules, and it will alert accordingly as you set up these. So I hope this wasn't too painful. I tried to keep it short because I know we are all here for actually get our hands a little bit dirty. Everyone okay? Anyone have questions at this point? Okay. So it's playtime. Before we head into the playtime, we're gonna log into our machines. We're not gonna install Prometheus because it's pre-installed for you to make it a lot easier. We're gonna we're gonna check out the sample config file. We're gonna start the node exporter, which is a system metrics gatherer for Prometheus. We're gonna install a simple demo application that we're gonna then query from the UI. Okay. So what I'd like you to do now is you have all these papers, right? You can use the web interface if you just type in your URL. That's a web SSH terminal, simple and easy. But you can use whatever SSH terminal if you want to, or if you prefer PuTTY, feel free to use. The user will be Playground, and the password you all got there. I also suggest you can open this GitHub link. I should have shortened it, but I didn't. So if you like, please open this GitHub link. You will see a README there that will help you through it if you get stuck anywhere. And possibly you don't need to type anything, you can just copy paste, okay? Okay. Right. So, if you do just list all files that are here, there should be 3 directories here. One is the fake application that we're going to use for our tests, the node exporter, and the Prometheus binary itself. So I'm just going to go into the Prometheus folder, and I'm just going to start Prometheus on its own for starters. Okay. Anyone familiar with Prometheus that have background knowledge? Okay, that's great. So it's going to be pretty new. Don't worry, it's not going to be any too deep. So if you don't follow, just please let me know, and I'll try to come and help you. Okay? Right. So once you started this server, you can just go to a new tab on your browser and open this very same domain name, but on the port 9090. Let's make it a little bit bigger. Okay. Okay. Yes.
On the card sensor key.
Yes.
Which one are we connecting to now?
Pardon? No, you connect the one that is on your paper. Yeah, I'm just going. Mine is Tuna. Sorry, I forgot to say. I have my own, right? Okay. Everyone managed to open the web UI? Good. So let's just spend like 2 minutes on this basically empty UI and see what's on it. First of all, obviously the first menu on the page is the alerts. We don't have anything there yet, but we at the end of the demo we put something in there because that's very funky. The next one is the graph. This is the default screen that comes up. This we're going to use to send expressions and queries to Prometheus, and we expect some metrics and graphs back. And all the other thing that I'd like to show you before we head any further is the status/targets, and see that on the default installation in the default config file, Prometheus only configures itself to check its own metrics. Okay, everyone got this, right? Super. So obviously we need to find targets for our little system. So if you go back to your SSH terminal and just, whoa, this is too big now. If you just hit the Control-C and exit this running process, let's check out a file called Playground. Oops, if I could type playground.xml, YML. It's a YAML file. It's a YAML config. Very, very popular nowadays, and I really like it because it's just like very simple and readable. Okay, so of the top of the config file, we have some global configurations. We're not going to touch on this. The only thing that we are really interested in here is the targets that we're going to configure here. We're going to have 4 targets. One of them being Prometheus itself. Then we'll have the fake app job we're going to use. This is actually 3 targets. I labeled 2 of them with this key value pair. It's going to be my prod instances, and the target here, the third one, will be a dev instance just for fun. And we're going to collect the node's own statistics with from the node exporter as well. So that makes us 4 targets. So we can start the Prometheus instance in the background. For that, we're going to do a regular no hop and then Prometheus. Feel free to copy paste from the GitHub. I'm just going to type it out. Prometheus web enable. All good. If you hit an enter, it's going to give you another message on the standard out, but you just hit another enter and you get back your prompt, so it should be fine. Okay. Now, if you head back to this UI that we just seen a few minutes ago, and then refresh this page, you'll see that there's something going on here. So it immediately gives us some feedback about our targets, what's happening here. Let me refresh again, like this. We have a fake app endpoint, or target, for which we have 3 actual services that we want to monitor, but they're all down. So that's a big down message. And obviously, because we haven't started any other processes yet, our node exporter is down as well. So let's just do that. Head back to your terminal, and then I'm going to head out of this directory, and what I'm going to do is, everyone's okay? Anyone have any questions at this point? Okay. So this fake application is actually created by Julius, one of the guys who wrote the Prometheus, the main contributor to Prometheus. What it does, it will generate lots of different fake metrics that we can explore the Prometheus UI with. Okay. So what we need to do here is we're going to have to start 3 services. Like this. I've just started one in port 8081. I'm going to start another one in port 8082. And I'm going to start one at port 8083. Right there. Guys, everyone can follow? Good pace? Slow? Quick? Too fast? Okay, I slow down. Need any assistance?
If I just run that, do you think it'll
Do you need any more time to catch up? Okay. If you need any assistance, just let me know. Feel free. No one bites.
Scrapes a lot slower on this complex deadlines. Yeah, whereas one of it so it connected, expected something to be like the real thing. I didn't get it to the point. Fake Christmas.
Need any hand, gentlemen?
How did you get the service running in the very beginning?
Yeah, that's running.
Is it running?
That should be running, yeah. Check.
I can see this. I can see the service running. Oh no, that's these running.
Okay.
But I don't get the UI on the UI.
Okay.
I don't get anything.
Right.
No, I don't.
Okay. Let's just go back to the terminal. Okay. So no such file. Are you in the which directory are you in? Prometheus. Okay. So no Prometheus. Yeah, that's the / there. That makes it a directory at the point. So available. That's double dash. Okay. Yeah. Okay. And you hit an enter.
If you do Control Z, stick it in the background.
Okay.
Background. No, just do VG.
Yeah, that works. Wonderful. Okay. You there? Okay. Right. Okay, let's carry on. So we started our 3 fake applications, and we're going to explore in a minute what actually is being generated in there. But let's just quickly start one more service that we haven't yet started, which will be the node exporter. For that, you need to do in the node exporter directory. You just need to run the node exporter command. Put it in the background, and hopefully it's gonna give you some data here, but don't worry, you just hit an enter and you get back your terminal. Okay? Now, if we head back to our user interface and refresh this, hopefully, and yes, now all our defined targets are up, which means we are getting some metrics in. So let's explore what's happening in there. Head over to the graph section and then open this little drop down here and see what's in here.
This isn't a graph.
Yeah, this is the graph page, so the second one from the top. Okay? Right. So as you can see, there's already lots of metrics are in, but yeah, let's just start with something very simple, okay? If you start typing, you can see that it will jump to, for example, this one, HTTP requests total. And let's just hit and execute and see what happens, okay? Yeah, that's all the data, exactly. So as you can see, as we talked about it in the slides, we have our metric name here. We have a value, and then between the two, there are some other dimensions, other key value pairs, which will be really useful for us to actually filter out something that we need or we don't need, depending on our needs. So let's just try this out. Very simple query. Let's find out.
Excuse me, I predefined
Pardon?
I predefined the HTTP request total, or is
this is something. It all depends what your application is exporting. A very good point, actually. So let's see what happens at the background, okay? Because that's quite interesting as well. So if you hit a new tab and open the same URL that you've given, open this 8081, for example, this fake application that we just started. Obviously, it will have a 404. Why? Because the metrics are. Yes. Yeah. Yes, I will. Trust me. Obviously, because Prometheus by default listens on the /matrix endpoint, which is with this demo application is the same. So we're using the default. We're exposing the matrix on the default endpoint, which is /matrix. So let's just type it in there, and if you hit an enter, you should see something like this. Make it like this. So I'm not going to over-explain it. Obviously, this is the raw data that goes into Prometheus in a format of metric name value plus key value pairs for the dimensions. If you see, one of the interesting things that I find is the way they define their descriptions and the types, which is they do a comment type definition. It's very interesting to see. Okay, everyone follows? So this is the data that we are gathering with Prometheus. All good there? Cool. Sure. Right. Let's head back. So if you just scroll down here, you will find lots of these that are defined. Probably not as well as HTTP request total. So let's just hit and enter again. Refresh the page. Now, if we want to filter it to something a bit smaller, because as you can see, there's many things here. But I don't care about all of these things. Let's just say I'm interested in our fake metrics that we generated with our application. If you just say job equals fake app, you should see something like this, which is very good, because I already sorted filtered some of the non-important things out, and then But obviously, we only see one value, the latest one. But before we head over to the graph, let's just put one more thing in there, because we can do that one as well. So if I say, okay, I'm only interested in the production metrics, let's just say env equals prod. We can filter it further. Very, very easy, but if you think about it, it's very powerful. Everyone good? Cool. If you head over the graph button, which is just over here, we can see that something is happening and something is growing in there. We have some kind of graphs. Now let's just resize this, because that makes a bit more sense. Now this can be a little bit weird. Why? Because it's an ever-growing number. So let me explain what this does here. So the metric's name is HTTP request total, which means the every given time frame, let's say seconds or milliseconds, I need to know what the total number of requests have being handled since the job started, the service started. Okay, but this is not very useful for most of us, because what we want to see is actually, in any given time, how many requests came in that time frame, which we can do very easily with something called a function. Prometheus has this concept of functions, which you can use to manipulate the data, to aggregate the data, to sort the data. We're not going to go too deep into that, because it's very, 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 very powerful, very, very detailed. But there's a very good documentation on Prometheus' website, which you can find, the link to it you can find on the bottom of the GitHub page, if you're interested.
And can you add regular expressions in the query? Or?
Yes, you can. We'll see that in a couple of minutes. Okay. Okay. So let's find a function that gives us something more meaningful data, more meaningful graphs that we have in here. What Prometheus thought was a good name for it, called rate. And what we're gonna do here, we're gonna see the rate that the data is coming in every second, averaged by a time frame that you wish. So what I'm gonna say here is, let's say 5 minutes. If I hit an enter here, I should be seeing something like this. Sorry, I put this back up here. Now what is this? So now I have the rate that the requests are coming in for that application. Now if you want to see what's really happening here when there's real data, let's just head back over to this test thing that we had in here and just refresh the page a few times. And remember that Prometheus is scraping data every 15 seconds. So if you wait a little bit and then re-execute the query, the expression, then we should see that something, oh yes, it's happened here. We had some requests coming in. So we're working live data. Everyone good? Questions at this point? Okay. Right. Okay. So what else can we do with it? Let's try something completely different. Okay. Let's say I'm curious about my node's memory consumption. Okay. Let's just check with something. Is it node? It's going to be node memory mem3. Let's see how much free memory we have. Okay. Okay, so it's called node underscore memory underscore mem3. Now, if you're not careful, you can end up with something like this. This won't be working. So what you really want to do is just get rid of this whole expression and either type it in. If you start type it in, you can see a sorted list, filtered. What's much like memory. Filter here. Now this is an actual. This is again a counter, but it's not increasing. It's a proper counter that we see that memory, the free memory on a node is decreasing. That's because our fake applications are crunching lots of memory. So, okay, we have this data, and most of the clever UI tools that you can plug into Prometheus, for example, Grafana, they are clever enough to actually sort aggregate the data and display it in display the accesses in like gigabytes or something. But let's say we don't have a clever UI, but we want to see the free memory in, let's say, kilobytes, because if we ever wanted to check if that's true, let's say we say top, let's say okay, that's 2,000,007 something, but this is a whole lot different. Like here, we can do simple mathematical, the most important mathematical functions, like okay, let's divide this by 1024. Now, what we have in here is a lot much more. It looks like much similar to this one, which is good. So we check that. Very good. So mathematical functions. Okay, let's see something else. What if I want to see in percentage that how much memory that is free? We can do as we can see if we browse this, we have a metric called memtotal, which is exported by the node exporter, the system matrix exporter. Let's just put it in there. Remember, if you click it, it's going to put it into the expression, so I should be fine with this. Okay, so if I just execute it like this, I can see a floating value saying, okay, 76% of your, well, 0.67 part of your memory is free. But I can, because we can do some basic mathematical things, I can just easily create a percentage of this by this. We just multiply it by 100. So that's very powerful, and you're gonna if you decide to try out Prometheus, you're gonna use it a lot, because it's a lot easier to aggregate data, for example, in Grafana, if you decide to use that, than just displaying single values and then stacking them together and whatever. Okay, so that's mathematics, and then also let's try something completely new again. Let's find one of our demo applications metric. It's going to be API request duration seconds count. No, don't be fooled by this name. It's just a name. Okay, it doesn't mean anything. So let's see what happens here. Oh, we have lots of data. Right. So, what if I said that I only wanted the ones that were, let's say, their status is 200. That's easy. Okay, we're good. What if I said I don't want 200? I want to see all the failed requests, so 404s, 500s. Easy. We already knew that if you ever dealt with any kind of scripting or programming, you will be very familiar with this this way of saying no. If you hit enter, you will see all the 404s, 500s, all the errors. Nothing 200. Everything but 200, to be exact. But the fun part starts when you say, okay, right. So I want to see all the paths that are ended in bar Okay, so how would I do that? I would say path, we can see that in here. So we want to say the path is, oops, something like, did I do it right? Yes, I did. Whoa, wonderful. So this answer to your questions, yes, it can be regex matching as well. Yes?
Do you have an ability to save any of these queries that you're making?
Okay, I haven't mentioned that. This application, this UI here, is purely for experimenting. It's not for any saving any queries. You would ideally use something like Grafana, for example, to do all of that and create dashboards and make it look nice. You would this is closer to the root. Okay, so you can experiment here. You can, for example, create the alerts that we're gonna see in a minute or two. You put it in your config file, your alerts config file, and then go ahead to Grafana and make the nice dashboards with it. So no, the answer is this UI cannot save any queries. If you can, all you can do is enable query history, which will save as long as your session is active. It's going to save your history of queries, but that's all about it. Okay.
Hey guys. Unfortunately, we lost sound of the microphone at this stage of the presentation, so I am gonna give you a little voiceover so actually you can follow through what happened in the playground. Notice that we can use logical expressions like not equals and regex expressions to filter our metrics. Okay, so let's get rid of quickly of this filtering here. And let's look at how the graph looks like when you have this many time series in your results. So if we go over to the graph section, we can see that, okay, this doesn't make sense at all. We have lots of time series. It's a counter, so it's ever increasing number. It doesn't look good. So let's use the rate function that we learned before to display the rate instead of the ever increasing counter. Okay, if I hit enter here, okay, what we're gonna see is we're gonna see the rate by which this request duration seconds counter came in, which can be a lot of help, obviously. Now let's reset the zoom to 1 hour. That's the default setting, and this is already very helpful. But let's say I don't care about any of these individual lines, but I want to display the whole thing in just one line. And a sum total is everything. There's a function called sum, which we can use for exactly this purpose, as you can see below. Now the sum function is very useful, but it summarizes all the time series into one line. So how about we don't want that? How about we want to see the summarization by status? Let's collect the time series filtered by the status. We can totally do that by using sum by. This is an extension of the sum function. Okay, so sum by, and let's say status. If you hit an enter here, if you scroll down to the bottom of the page, you will see that we have 500s, 404s, and 200s collected. But let's say we don't really care about the 200s because we have a lot of them, and but we might be missing some important information because it's not showing up correctly on the screen. So what if we want to get rid of this 200s? We just enter the filter, status not equals 200. So now we can see the 404s and the 500 errors, and this can be very useful for us to display or to alert on. If you were there on the playground this day, you remember that around this time the the pizza has just arrived, and we decided to rush up the end of the presentation a little bit, so we can keep the pizza a little bit warm. So jumping to the end of the demo, what we are missing is the alerting bit. We haven't talked about alerting so far. So what we're going to do here, we're going to create an expression that we're going to use for alerting that uses everything that we learned so far. There's going to be rate, there's going to be sum, there's going to be mathematical expressions, and there will be a new one called condition, which is essential for alerting. So in the past we used the demo API request duration seconds count, and for the last part of the demo we start with a very similar one called demo API request duration seconds sum. Let's do rate. Good. I haven't told you, so demo API request duration seconds sum is the metric that collects the actual time spent serving the request in this demo application. So if you want to know, if you want to know something useful, we would like to know ideally how much time we spend on serving a request. So we have the count, we have the sum. If we divide the sum by the count, we will get how much time we spent on serving one single request, and that's what we are doing here. So after executing the query and jumping to the graph, we can see that we saw something like this before. There is lots of different time series, which we probably want to summarize by something. So let's use the previously looked at sum function, and let's summarize all these requests by status. So if you follow the screen, you can see on the graph that serving the 404s are very quick, but serving the 200s and the 500s can be take very long time. This is the graph is by seconds. Don't forget to create a condition for our trigger in alerting. All we need to do is look at our graph and decide what's the healthy limit, what's the threshold. And once we decided that, we just simply put it at the end of the expression, which will work as a trigger in alerting. But we can also see the results in our Prometheus UI as well. So if I do just that, and then hit an enter button, and look at the graph, we'll see that we ignored everything that was below this 0.4. So we don't care about that anymore, which means we have a trigger. So after that, all I need to do is actually write the configuration for the alerting section. So all we need to do is go back to our terminal and write these config files, right? So let's find our Prometheus directory, which is, if you were on the playground, that was in the Prometheus dir. And in there is an example file already created for you, which looked like this. And if we inspect this a little bit, let's focus on the first section, okay? So we have an alert that's called instance down. That's the name of the alert. We have an expression by which we are triggering the alert. We have a for indicator. For is we're looking back for 1 minute in this case to evaluate whether or not we are triggering this. And then we have labels and we have annotations. Okay, so one thing I haven't talked about is the expression that we have here, up e double equals 0. That means that if any of our targets is down, then this alert is triggered. Okay? Okay, so what we're gonna do here in the other alert that we configured, if you see the expression, you see that it's pretty much the same that we used just back in our Prometheus UI browser tab. I probably gonna modify that just a little bit so we can see the alert is going off. Okay, so we are in the Vim editor, and all I'm going to change here is I'm changing the 0.3, the 0.4, that's the condition, and all. The reason why I'm changing is because we want to see it triggered in the UI. So someone in the audience asked me to show the line numbers in the Vim editor. So if you don't need to do that if you don't want to. Okay, so we modify the file. Now we have one thing missing here, and that's that this config file is not loaded to our main config file. So we opened up the main config file, the playground YAML that we use to start our Prometheus instance. And then insert 2 lines in there, which currently I'm copying from the GitHub repo, and what it does is simply loading the alerts rule configuration file. That's all it does. So we have one more thing left to do, which is reloading the config file for Prometheus. And that can be done by just reloading using a curl command to reload the config file. And the reason why we can do that is because we enabled this with a special flag that we used when we started the Prometheus process. So let's issue the command, and then after we did that, we can just head back to the Prometheus UI, maybe refresh the page. And once we refresh the page, we go to the alert section to inspect what we have done. If we did everything right, we have 2 alerts configured now. The one is API high response time, the other one is instance down. The instance down is already 0 because all of our targets are up, and the API high response time is currently in a pending state. And the reason why it's in the pending state is because we don't have enough data to make the decision, because we are triggering the rule every 1 minute, and we refresh the page before waited 1 minute. So that's that. If we waited long enough, it would be triggered. Okay, so let's recap quickly what we've achieved today. So we learned that Prometheus is a modern monitoring tool which has a very, very powerful query language called PromQL, with lots of built-in functions. Remember, we only saw like 2 or 3 of them. So please make sure you check out Prometheus's documentation about all the functions and all the various bits and bobs that it can do. We learned that it has a single binary approach. It's modular and individually scalable. We also installed and configured the exporters in Prometheus itself. We looked at some rule metrics. We explored the basic query features, and we have quickly configured an alert. This concludes our demo and our presentation. So if you liked watching this video, please make sure you come over to our next playground in the next month. Thank you and goodbye.